for each term that's directly below, it's the sum of the two digits above it. And we're talking about the ones that are direct. Hey, how are you? All right. Thank you, studies. Oh, I did.
Oh, I see it.
Someone called more loud.
I guess one's for Brittany Patrick.
Oh, thanks, Miss Kate. Oh, Miss Mass. Miss Mass is such a sweetheart.
What's happening here? 2 is the sum of 1 plus 1. 3 is the sum of 1 plus 2. 10 is the sum of 4 plus 6.
There's ones on the outside.
Ones stay on the outside, ones will always continue on the outside all the way down. Because what this is mirroring, what this is mirroring,
Do we have to write this down?
no. What this is mirroring is the following. 0, choose 0. 1, choose 1. Or excuse me, 1, choose 0. 1, choose 1. 2, choose 0. 2, choose 1. 2, choose 2. 3, choose 0. 3, choose 1. 3, choose 2. 3, choose 3. Oops. And so on and so forth. What Pascal's triangle is built off of is combinations. On the left-hand side, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way on down. 2, choose 0, 2, choose 1, 2, choose 2. Start over. 3, 0, 3, 1, 3, 2, 3, 3. 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. And so on and so forth. What this actually allows us to be able to do is that it helps us to do what's called binomial expansion. Binomial expansion is something along the lines of taking x plus 3 to the 4th power and writing it out faster. Because if I had to expand that out, I'd have to do a whole lot of FOIL, a whole lot of combining like terms. Well, there's a formula to help us do this easier. And it's called binomial expansion. So what do we have? X plus 3 to the 4th power. Here's what we do. This mirrors A plus B to the n. I'm going to use that as its generic.
We don't have this one.
No. In order to do binomial expansion, you do the following steps. N, choose 0. A to the n, B to the 0. That's your first term. Your second term. N, choose 1. A to the n minus 1, B to the 1. Yes, sir. You'll see how fast this works. Plus n, choose 2.
That n
A
minus
to the
1.
n minus 2, b squared. Plus n, choose 3. A to the n minus 3, b to the 3rd.
I'm gonna run out of room for my paper.
It's continuous. It depends upon what your n value is.
This is easy.
Here's what's happening. What is happening to the coefficient? What's the exponent of a doing?
Stays the same. It's constant.
Well, it's getting small.
It's getting smaller. It's going down a degree each time. The value of n for the a term, it goes down once each term. The exponent of b starts at 0 and works its way up 1 each time. This n choose 0, n choose 1, n choose 2, that's the leading coefficient for the next exponent. Yeah? You don't need one for this. Here's why.
Do not see how long that is.
You don't need a formula. Watch. Seriously, watch this. What's your value of n in this question? 4. 4, choose 0. What's a?
A is A.
X. X to the 4th, 3 to the 0 power. Plus 4, choose 3. X cubed, 3 to the 1st power.
Why'd you immediately go to 3?
I go down a degree each time. I go up a degree each
Oh,
time.
I see, alright. But then choose 1. So why is it 4 choose 3?
Oh, sorry, it's supposed to be
Yeah,
1.
it should be 4
Sorry.
choose 1, and then X.
4 choose 2, x squared, 3 squared, 4 choose 3. And then you go all the way till you get to, guys, once your leading to your a value reaches an exponent of 0, you're done. Your b value starts at 0 for an exponent, and it goes up to whatever the n value is. You're going to know these really fast. 4 choose 0 is 1.
Is anything choose 0?
Yeah.
Same with anything choose the same as it was.
Yep.
Is 1.
Yep. When I go for here,
And we put this in our
4
calculator.
your calculator won't do this. 4 choose 0 is 1. 3 to the 0 power is how much?
1.
What's 1 times 1? Okay? 4 choose 1 is 4. 3 to the first power is 3. X cubed. 4 choose 2. I think it's 6. Yeah. 4 choose 2 is 6 times 3 squared, which is 9. X squared.
That was just some horrible factoring problem.
Foil. You're foiling it out. You're multiplying out. You're expanding it. Factoring is condensing. Okay. 4 choose 3, I believe is it's 3 again.
Oh, it's 4. 4 choose 3.
Oh yeah. 4 choose 3 is 4. 3 cubed is 27 times x. And then 4 choose 4 is back at 1. 3 to the 4th is 81. X to the 0 is 1. All this is doing, guys, what this is doing is allowing you to get the coefficients together with your degrees of your exponents as you're working your way down. You wind up with x to the 4th plus 12x cubed plus 54x squared, 2754, 108, x plus 81. If I would have FOILed out x plus 3 to the 4th power, I would have eventually gotten to x to the 4th plus 12x cubed plus 54x squared plus 108x plus 81. What you're doing here is you're working with your exponents. Your exponents for your first term start at whatever the n value is, works your way down to 0. Your b value starts at 0, works your way up to n value. Your choose ones, whatever n choose 0, all the way up to n choose n. And those are how they work through. You will see the pattern within the numbers are relatively easy. Let's try another one.
That's where we leave it at? We don't
Yeah,
go any
you
further?
just FOIL that. What you're doing is you're expanding the binomial. You're FOILing the whole thing out.
So we're not actually solving for
You're not solving for x. Okay?
So for on the homework that
That's your answer.
So the bottom.
Yep, that's your answer. No, I'm not solving for x. Let's say it's x plus 2, bless you, to the 5th power. If I do x plus 2 to the 5th power, that means I have to do x plus 2 times x plus 2 times x plus 2 times x plus 2. No, it's not.
with your calculator.
So 5 choose 0, x to the 5th, 2 to the 0. 5 choose 1, x to the 4th, 2 to the 1st. 5 choose 2, x to the 3rd, 2 squared. 5 choose 3, x squared, 2 cubed, plus 5 choose 4, x. I'm not showing off. Yes, ma'am.
This shows out.
First term, second term. They just go with first term, second term. If there's a subtraction symbol in here, if it's a -2, make sure you put that -2 within parentheses when you raise things to the exponents. So 5 choose 0 is 1. 2 to the 0 power is 1. So I just wind up with x to the 5th. 5 choose 1 is 5. 2 to the first power is 2. X to the 4th. 5 choose 10. Or sorry, excuse me, 5 choose 2, isn't it? I think it's 10.
Yeah, it's 10.
Is it 10? Okay.
Yeah.
So that's 10 times 4, so that's 2 squared, x cubed. 5 choose 3 is also 10. Am I right?
Yeah.
Oh, I know that? Because it is.
9.
Because remember, 10 factorial, or sorry, it's 5 factorial, and then it's 5 minus 2 factorial times 2 factorial, and 5 factorial, 5 minus 3 factorial, 3 factorial. I did. This is 5, 4, 3, 2, 1. This is 3, 2, 1. This is 2, 1. These drop. 2 becomes here. 5 times 2 is 10. Other here. 2 times 1, 3 times 2 times 1. This is 5, 4, 3, 2, 1. 3, 2, 1s drop. 2 drops out of here. 5 times 2 is 10.
Three, two, one, and 2.
They both said 3 factorial. You can't pop that 3 or no?
I did. Yeah, sorry.
That's what confused me.
Yes, ma'am.
Alright, so it goes from X to the
Which one?
That's the one.
No. So now we're at 10 times 2. 2 cubed is 8. X squared. 5 choose 4. We are back at 5.
So you can just do that in your head? The factorial thing?
It's a pattern. 1, 5, 10, 10, back to 5, back to 1.
Oh, that's what the pattern.
Duh!
Oh,
You think I'm
get
that
it.
good? I'm appreciating that.
Oh.
1, 5, 10, 10,
One,
5, 1.
oh my god. 1, 4, 6, 4, 1.
5, 10, 10, 5.
If you,
Opened with
That is so easy.
if you look back at Pascal's triangle, this is your n equals 0, n equals, I'm sorry, this is n equals 1, n equals 2, n equals 3, n equals 4,
I'm
n
gonna
equals
solve
5.
this thing to like 20 digits.
1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5.
deal with you.
I've already got
1.
Pascal's triangle all the way to 10.
That's where it's coming from.
So, is that question for you? As a short guy, I feel like I'm thinking more can you use the test method? Does it work?
So when you multiply all that out, you're left with x to the 5th,
Mr. Murphy,
10x to the 4th. Yes, sir.
if I figure out Pascal's triangle all the way to 100, can I get a credit?
I don't care. I'm not going to get you credit for it. That's pretty impressive, though. 32, 32, 64. 64 and 16 is 80.
Yeah, that'd be pretty awesome if I get to 100. It's like take up the entire wall.
Okay. Again, the only thing I'm going to warn you about when I give you a couple of these problems is to watch out if the b value has a negative around it. Just make sure when you're raising it to the exponent, you're putting it in parentheses as you type it out. So if you have to do -3 cubed, make sure you put that in. Okay? Yeah.
So we don't have to do anything else
That is your final answer. You have nothing else. Well, all you're doing is you're expanding it out to what it would look like prior to being jumped in, like jumped to the fifth. Okay?
Can you show us
I am the leprechaun.
Wow. That's my story. I can appreciate that story.
I want you guys to do the same page stuff. It's 712.
This just made things so much easier.
36.
The end, every time.
Yeah, it's fine.
the end is, like,
It's not scary for me. I got something better.
Yeah, I wrote down the page.
It's the same section, 12-2.
Can you leave it up on the board?
Corresponding rows of cascade triangle. As you go through them,
So we do need to know this formula or we don't?
build a pattern.
Brittany, why is that funny? Because she laughs at her brain. It's so freaking funny.
Yes, sir. All right, I'll get it. 1 second here. You just throw it. That's, yeah, I'll get it.
So this, the answer is the same?
Yes, it is. Because this is n equals 0, n equals 1, n equals 2, n equals 3, so on. So 5, n choose. So if you have 5 choose 0, it's 1. 5 choose 1 is 5. 5 choose 2 is 10. 5 choose 3 is 10. 5 choose 4 is 5. 5 choose 5 is 1. 6 choose 0 is 1. 6 choose 1 is 6. 6 choose 3 is 15. 6 choose 4 is 20. 6 choose 5 is 15. 6 choose. I got lost there. Whatever. That's how that works.
Okay, so why, how does that help?
These are, when you're multiplying that out, that 5 choose 2, well that's 5, the second one choose 2, that equals 5, times that x to the whatever n minus 1. You're just putting those together.
That's so rude.
If you know what some of these are, quicker, it's not a big deal. You don't have to memorize Yes. When you're working on the Pascal's triangle,